Hi everyone, this is Tamimi, a developer advocate from Solace. And today I'm going to talk about the OpenTelemetry demo that is provided by the open source community found on OpenTelemetry.io. This demo architecture is created by the open source community to showcase different features of OpenTelemetry and how tracing and distributed tracing is supported in an architecture that has different layers, including HTTP calls, gPRC, and messaging components. So as you can see here on their website, OpenTelemetry.io, under the architecture section, there is a messaging component where the checkout service of this e-commerce application publishes a message to a Kafka queue, and then there is two different services, the accounting service and the fraud detection service, that subscribe to queues, to topics on the Kafka broker. What this demo will show is how we can extend this architecture diagram to include a Solace broker right next to the Kafka broker to showcase how context propagation is supported within the Solace broker. So first, I will go ahead and go to our Solace Dev OpenTelemetry demo. This is a forked version of the demo where you can see there's a branch for Solace support in there. So what I'm going to do is I will go ahead and clone this repo locally. So I will go ahead and clone this repo. And once I'm in this repo, I'm going to check out the um, Solace support branch, and following the steps in the documentation of this OpenTelemetry demo, I'm going to go ahead and build all the Docker components, all the Docker images in this demo. So what's happening over here is behind the scenes, we are pulling all the different images and the containers that are involved in this demo. So I'll go ahead and wait for it till everything is downloaded and built. While this is building, I'll go ahead and explain a couple things about this architectural diagram for this demo. So this demo is composed of different components. I'll go ahead and delve into more details about the demo and what it does. It is an e-commerce website where there is a front-end website, and it involves different other microservices in the back end. Anytime there is a purchase or an activity on this e-commerce website, it goes into the checkout service. There are other services from payment services, ad services, fraud detection, and accounting services are also involved in this overall end-to-end application. Every time there is an activity that happens in any microservice, let's say it starts from the front end and it propagates through different microservices in this architecture, every microservice and every transaction between microservice will generate spans that will go into the OpenTelemetry collector, and we'll able to see that in an observability backend. Let's go back to our Docker Compose to see if everything is built. So there you go. All our Docker images have been pulled, and now the application is running. If you go to the Docker section over here and see what are the different services that are built and run behind the scenes for this application, we have a web store that is hosted on localhost 8080. We do have a Grafana and a Jaeger UI for our OpenTelemetry related information. And then there is two different features that are also associated with this demo, which is feature flags and load generators. We'll go ahead and open and see what these two different features show. But for now, let's go ahead and see what the web store looks like. So this is an e-commerce site where it shows different products. You can go ahead through the different process of the products, add to cart, and then proceed to checkout by placing an order for a product. And you can go ahead and see what you can do with this application. Other features associated with this demo as well, you can see there is a Grafana dashboard and a Jaeger UI dashboard. So I'm going to go ahead and open the Jaeger UI dashboard to take a look at all the different traces that are emitted and generated within my overall architecture. So I'm going to find traces that are associated to my accounting service. So you can see here there are so many different spans that are generated and different traces for every action. So if I click on one particular trace, I can see the different spans associated to that particular trace ID. There's one particular thing I want to take a look at and focus on is the checkout service. You can see here the bottom two checkouts service. This one is emitted to Kafka and one is emitted to a Solace. So these two particular spans that are generated are messaging related to your demo. So it is important, it's critical over here to point out a couple of differences. So the spans that are generated every time you publish to a Kafka topic, you can delve more information, more details about every span. And then you can see that this is a topic. The topic name is orders, and then there's another topic as well, destination orders for both the accounting service and the fraud detection service. These spans are generated on the API level every time there is a consumption from a Kafka topic. The same particular activity is also published to a Solace broker, and you can see there's a bit more details within the Solace broker that shows what happens to the message when it's being received. So the checkout service publishes a message on a particular topic to the Solace broker, and then the Solace broker will generate spans saying that it received the message. We can delve into more details about this particular span and see that the message destination, so this is the topic that the message was being published on. So we see that the topic published was includes the orders, some order ID, the country, state, and more information about the particular activity or transaction that happened. So this also shows that the topics are very dynamic in the Solace broker, and there's more information about that particular message that got published. So you can see details about that message. So this also gets then further propagated down. So we see that the message was received by the Solace broker and then it was sent. So you can see here that a send span is being generated from the Solace broker to prove that the message was sent to the client. And then the accounting service, when it received the message from the API perspective, so you can see here, I'm going to zoom in a little bit and say this is the Solace Go API receive. So the accounting service publishes or emits a receive span from the application layer, showing that it received a message and more details about it, what's the topic of that message, and you can see here that this is a consumer that generated a receive span. The same kind of information is also generated for the fraud detection service. So we know here that the Solace broker emits two send spans, one to the accounting service and one to the fraud detection service. So with this, we were able to dissect further the details associated with the Solace broker generated within the overall infrastructure. If you want to run this application, so feel free to go to Solace Dev OpenTelemetry demo, check it out, build the application locally, and following the steps and instructions associated with the OpenTelemetry demo documentation. Thanks.